All right, this is AP, AB, and BC Calculus. We are doing Unit 5, Section 3, which is determining intervals on which a function is increasing or decreasing. So same standing reminder that you should not use pronouns when describing a function. You shouldn't say it is increasing. That will always be marked wrong. F of x is increasing, f prime of x is increasing, g of x is increasing, but never the word it. All right, so recall that in the very simplest sense, derivative means slope, right? And that's a drastically oversimplified view of the situation, but when you're trying to understand the logic behind this, that's a really good way to think of it. Recall that lines with a positive slope are said to be increasing, so lines that look like this, right? And lines with a negative slope are said to be decreasing. So we can extend that logic to talking about f prime of x and realize that when f prime of x is positive, we are talking about a function f of x that is increasing. And when f prime of x is negative, meaning less than 0, that we are talking about f of x decreasing. So from 5.2, we know how to find critical numbers, which is when f prime of x is 0 or does not exist. For f of x. And from Algebra 2 and Pre-Calculus, we know how to make sign charts. In this section, we're going to put those two scales together to determine when a function is increasing or decreasing. And then in the next section, 5.4, we're going to use the same sign charts to determine extrema. Okay, so I am reusing the functions that I used in the last video. I'm doing this largely because I wanted us to be able to quickly get to the part where we actually make the sign charts, because in a more difficult problem, you're going to have to do all the steps all together at once. So in this situation, I wanted to try and make it as easy as possible for us to just go ahead and use the functions that we already had. So in this case, I found my f prime while I was talking to you just now. It is 3x squared plus 10x plus 3, and then I factored it into 3x plus 1 and then x plus 3. So if I want my critical numbers, right, so my critical values or critical numbers are going to be either when f prime is 0, which will be at x equals negative 1/3, right, because that's when this would be 0, or at x equals negative 3, right? When f prime does not exist, which is never in this case because it's a polynomial. And then the other thing I have to worry about is those included endpoints, right, which in this case happen at x equals negative 10 and 0. So what we're going to do is we're going to take this information and we're going to make a sign chart. So there's a bunch of different ways to make sign charts. The best way to make sign charts as problems get more difficult is going to be to list the factors. So we're going to make an f prime sign chart. We're going to list the factors, x plus 1, x plus 3. We're going to start our sign chart at our included endpoint. And list all the critical numbers in ascending numerical order, and then we're going to end at our other endpoint, and these would be infinities if I were going on forever in both directions. What that means is that f prime is going to be the product of those factors, right? And from that, I'm going to be able to see what f of x is doing. So this is my f prime sign chart, and see how I clearly labeled what I'm looking at, right? So, so basically what's going to happen is 3x plus 1. You can either pick a number in between these values, which is fine, although I think you'd be hard-pressed to find an easy number between negative 1/3 and 0. Or the easier way to do this is to recognize, as we've seen in sign charts in Algebra 2, that 3x plus 1 is a line with a positive slope. So if it's 0 here, it is below the x-axis before it crosses that 0 and positive after. By the same token, x plus 3 is also a line with a positive slope, so it is 0 at negative 3, negative before it hits that 0 and positive after. What that means is that the product, negative times a negative, will come out positive, negative times a positive will come out negative, and positive times a positive will come out positive with zeros at these lines. So what that means f is doing is f is increasing, decreasing, and then increasing again. And you can kind of already see how this is naturally going to lead us into 5.4, where we're able to look at these little up and down arrows and determine where the extrema are. But in this section, all we're doing is increasing and decreasing. So from this, my answer is going to be that f of x is increasing on this window, right? So it's increasing starting at negative 10, which is an included endpoint, to negative 3, open parenthesis because it's not increasing at negative 3. And then it's increasing again from negative 1/3, again open, to 0, which would have a bracket, right? Because that's an included endpoint. And that f of x is decreasing, right? F of x is decreasing on the window in the middle from negative 3 to negative 1/3. Now, I did say that there were different options for sign charts, so I just want to show you what I mean by that. The other option, and it works really well here where f prime is just a parabola, right? So we know that f prime is a 3x squared plus 10x plus 3, and we know that its two zeros happen at -1/3 and -3. Here's the honest answer. You can kind of cheat. You could label this number line as f prime, and you could put the two zeros in numerical order ascending, right? And then you could recognize that f prime is a smile, so if those are the two zeros, it has to look like this, meaning that f prime is positive, and then negative, and then positive, which confirms exactly what you can see on the sign chart above it. Now this works great. This kind of visual sign chart works absolutely great if you're dealing with something as simple as a polynomial, right? X squared, great, totally easy. It doesn't work so well when we get to those functions that involve sines and cosines or e to the x. So I'm going to advocate that in the long run, this is the better plan, but that certainly for these easier problems, it would be fine to do this kind of visual sign chart. All right, let's move on. So again, we've already found the derivatives of these things. If you want to go back and look at your notes from the last section, right, we've already found these. So I'm going to yank out a 4x squared and be left with an x minus 3. Okay, so we already know that the critical numbers are at 0 and 3. So these are when f prime is 0, right? We know f prime does not exist, is not an issue here because there's no denominator. And we know that we have endpoints at -2 and 5, right? So again, if you wanted, if you know cubics really well and you want to make a sign chart for this, you absolutely could just do a visual sign chart. I'm going to advocate that moving forward, you get used to making the much more useful and extensive sign chart where you list things, where you list all of the factors, right? So my factors of f prime, you can either list this as a 4 separate and an x separate and another x separate, or you can call this a 4x squared, and we'll talk about what that looks like in a sec. And my other factor is an x minus 3. I'm going to label that this is my f prime sign chart, right? And then below that, I'm going to label that I want to know what f is doing, right? So let's start with the x minus 3. X minus 3 is a line with a positive slope. It looks like this. Its 0 is at 3, so it's negative before it hits that 0 and then positive after. You could also have figured this out by picking an easy number like -1, 1, and 4 and just plug those numbers in. That's fine. 4x squared's a little trickier. If you picture what 4x squared looks like, it looks like this. It only has a 0 at 0, and it's positive the rest of the time. So it's going to look like this. Now, if you don't see that right away, you can see it by plugging in the numbers I suggested, but it's always positive. So f prime of x is going to be a negative, 0 on the line, negative again, because positive times negative, 0 on the line, and then positive. So my f is decreasing, leveling out for a sec, decreasing again, leveling out, and then increasing. Again, I think this is leading us pretty naturally to the next section where you're going to be able to use these really little weird squiffy looking line drawings to find the extrema, right? So in fact, from what we discussed in 5.2, this is a saddle right here, right? At x equals 0, that's a saddle. But if you were giving the answers about when this function is increasing or decreasing, so f of x is increasing, right? So f of x is increasing on the interval from 3 to 5, and the 5 is included because it's an endpoint, right? And this is also an endpoint. Now, f of x is decreasing is an interesting notion. So there are two sort of ways to phrase this. F of x is decreasing from, sorry, there's a bracket at -2, right? From -2 until it gets to here, which would be at 3. Now, some of you are probably thinking, okay, but what about at this 0, right? So if I asked you when f of x is strictly decreasing, so strictly decreasing, so f of x strictly decreasing would be this window to 0, and it would skip over 0 and go to 3. So the issue is that f of x decreasing can include when f prime of x equals 0 if it's negative on both sides. So see how f prime was negative and then continued to be negative? It can include that spot where it's 0. But strictly decreasing is f prime of x is less than 0 only. Okay, so you can include those zeros, right? You can include those zeros. Essentially, f of x can be considered decreasing when f prime is also 0 as long as it's sort of wedged between those two decreasing values, okay? So either of those answers would be acceptable, but realistically, and like if I were taking this on an AP, I would be extra safe and I would say something like, it's decreasing on this interval, but it is strictly decreasing on the interval not including 0, something akin to that. All right. So again, we've already found these derivatives. There are no endpoints in this problem. We're asked when this is increasing or decreasing. So f prime of x is going to be, remember that this was actually an x squared minus 4 to the 1/3, right? So what we saw before is that this is a 1/3 x squared minus 4 to the negative 2/3 times that 2x for the chain rule. So what we found in the last video was that my critical numbers, when f prime is 0, that was only when 2x was 0, so at x equals 0, right? My f prime did not exist, if you recall, when x squared minus 4 was 0, which is the same as positive and negative 2, right? So x equals 2 and negative 2, right? And then we don't have any endpoints, so there are no ends, right? There were none given. So my sign chart's going to have to include 0, 2, and negative 2. Now this is where we start to step into that world where you probably don't know what this graph looks like off the top of your head. So you want to make sure that you make this sign chart, right? Because this is not like an x squared where you can just say, okay, cool, that's really easy. I know what this looks like. So when we make this sign chart, right, my factors are the 2x, right? And then on the bottom, right, there's a bunch of different ways to deal with this bottom value, right? I would suggest that the easiest way to deal with it, there is a 3 on the bottom. The 3 does not really affect much. I mean, technically, so this is on the top. In the denominator, or I guess we'll use n for numerator, that's on the top. In the denominator, we have a 3. Great, doesn't matter much. And then this thing, right, so this, just to clean this up a little bit, when you have an x squared minus 4 to the 2/3, that's the same as an x plus 2 to the 2/3 and an x minus 2 to the 2/3 because it's multiplication and you can distribute a power on multiplication, right? Because this is x plus 2 times x minus 2 whole quantity to the 2/3. So basically, an interesting thing's going to happen here. I'm going to make my other two factors from the denominator an x plus 2 to the 2/3, and I'm going to explain to you why that's weird in a second. And the other factor in the denominator is an x minus 2 to the 2/3. Okay, so those are going to be my factors. Then again, this is definitely stepping it up in terms of a sign chart. Like, this is much harder. The numbers that have to show up on my sign chart are negative infinity, because there was no endpoint, negative 2, 0, 2, and infinity. And I'm tight on space, but I don't need anything to go after infinity. And all of these together are going to be my f prime. Right? So all of these together are going to be my f prime, and then I want to know what f is doing. So 2x is pretty straightforward. It's 0, right, at 0, and it's a line with a positive slope. So it's negative before it hits 0 and positive after. 3 is also very straightforward. It is literally always a 3. The two that are going to tend to be tricky to people are these bottom ones, but what I want to show you is that they have an even power on them. The root part doesn't matter. They have an even power. That means they're going to net positive. They are something squared. So this thing is 0 here, but it's going to be positive everywhere else because of the even power. This is a 0, and this is going to be positive everywhere else because of the even power. And if you're not sure, if you don't believe me when I say that, you can try plugging a number in. You can try plugging in 1 and negative 1 because those are easy numbers. If you plug in a 1, right, let's say you plug in a 1 right here, you're going to get the cube root of negative 1, which is a negative 1, and then you're going to square it and get a positive 1. It's totally going to net positive. So knowing that, I have a negative times 3 positives, that's going to net negative. I have a negative times 3 positive, that's going to net negative again. I have a bunch of positives, that's positive, and I have a bunch of positives, net's positive. Oh, and actually I need to change the thing real quick. Hold on. I meant to get the eraser, and I accidentally have the giant eraser, so let's fix it. These are not places where it's 0. These are places where, so it's worth noting that these were D and E places, right? So this is a spot where there's D and E for the derivative. Something's wrong, right? It's going to be pointy or cuspy, right? So something's weird's happening. So now what we know about f is we know that f is decreasing, then decreasing again, then increasing and increasing again, okay? So if I'm asked when f is decreasing, right, f is decreasing on this entire window, but there's an issue that happens right here, right? There's an issue that happens at that 2, right? So what's happening here is essentially f is decreasing from negative infinity to negative 2, and again from negative 2 to 0, right? It's not doing either increasing or decreasing at 0, and then it's going to increase from 0 to 2, and again from 2 to infinity. And we can actually look at what these graphs look like, and then when you start to see them, they start to make a little bit more sense. But again, we're just looking for the windows where f is increasing or decreasing in this particular video. In the next video, we'll talk about extrema. All right, same idea, right? So we've already found this derivative, and I'm just going to go ahead and jump ahead and do this. This is going to end up being a 2 over 3 x plus 3 to the 1/3, okay? So we already found that there's no places where f prime is 0 because 2 equals 0 is a lie, right? We found that f prime does not exist, and again, this was in the previous video where x plus 3 was 0, so at x equals -3. That's the only number that's going to go on my sign chart, right? So when I list my sign chart, it's going to go from -infinity to -3 to infinity. My factor on top is a 2, and I do need to list that factor, right? On the bottom, so that's on the numerator if that helps, right? In the denominator, I have a 3. You should list those numbers because if the numbers are negative, it's going to make a difference, right? I have an x plus 3 to the 1/3. Okay, so that means that my f prime, right? Notice I make sure to label it as an f prime, and remember that there's nothing after the infinity, so I didn't really need that space. So 2 is always positive. The reason it matters that you list coefficients on here is because if a coefficient's negative, it's going to change all the signs. 3 is also always positive. Now this guy has an odd power, which basically means like he's just going to behave like the thing on the inside. So the thing on the inside is aligned with a positive slope, meaning he's going to be negative before he hits 0 and positive after. So I get negative and positive, which means f is decreasing and then increasing. So f is decreasing on the window from -infinity to -3. F is increasing on the window from -3 to infinity. All right, moving on. And again, I am kind of blowing through these derivatives pretty fast because we did them in the last video, right? So, so when I find my f prime of x, I end up getting 3 sine squared of x cosine of x, right? And in the window that we have, we ended up last time finding that the critical numbers happened when x was 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the reason for that is because if you look for where sine is equal to 0, right, at these three values, sine is equal to 0, and at these two values, cosine is equal to 0. That's why we get those 5 values. F prime does not exist was not an issue because there's no denominator. And we do have n's, but the n's were already listed in the problem because 0 and pi over 2 are already choices in the problem. So now when we make this sign chart, I think you're going to find this a little bit different. I'm going to actually scroll down because we have a lot of sign chart to make, right? So when I make this sign chart, I know my n's are 0 and 2 pi. Pi over 2, pi, 3 pi over 2. I'm going to show you a slightly different technique when we talk about trig functions. So I know that there's a 3 in front. I know there's a sine of x. Now it's sine squared, so you can either write it as sine of x quantity squared or you can write sine x twice. I don't care which one you do. So just be mindful that this is the y on the unit circle quantity squared. And this one is cosine of x, which for the record would be the x on the unit circle, right? So those are my factors, right? So this is my f prime sign chart. And so f prime, I'm going to get a sign for f prime based on that product, right? And remember, there's nothing after 2 pi. And that'll help me figure out when f is increasing or decreasing. So here's my hint for this. These are quadrants. You know that 0 to pi over 2 is this quadrant. So you don't need to plug in a specific value to know what sine is doing in that quadrant. This window is this section. You can figure out what sine and cosine are doing in that quadrant. This window is this section. And this window is this section of the graph. So I know that this is a 3 all the time. It's a positive. It's fine. I know that sine is 0 at all the pi's, like 0, pi, and 2 pi. So then if I picture, first off, this sign is being squared. So actually, it really doesn't matter whether the sign would be positive or negative. It doesn't matter if the y in the unit circle is positive or negative because I'm squaring it. So it's going to net positive anyway because of the square, right? Now, cosine is the x value on the unit circle. So in quadrant 1, x values are positive, right? At pi over 2, cosine is 0. Same thing at 3 pi over 2. In quadrant 2, x values are negative. In quadrant 3, x values are negative. In quadrant 4, x values are positive. So I end up with a positive, negative, negative, positive, right? Which means f is increasing, decreasing, decreasing some more, and then increasing again, right? So this is one of those strictly increasing or strictly decreasing situations. So f is increasing is pretty straightforward. F is increasing, and you can include the endpoints if you want, because so if I say f is increasing, I'm going to include the endpoints, but we know that the endpoints are actually spots where it's 0, right? Where the derivative f prime is 0. So I could say f is increasing from 0 to pi over 2, and from 3 pi over 2 to 2 pi, that's a parenthesis, to 2 pi. But if I wanted when f is strictly increasing, so just to be clear, if I say f is strictly increasing, then there would be no brackets, because strictly increasing means that f prime can't be 0, right? So strictly increasing would look like this, okay? If I say f is decreasing, well, f is decreasing on this entire window, which was from pi over 2 to 3 pi over 2. So I could say from pi over 2 to 3 pi over 2, right? But if I say f is strictly decreasing, I'd have to cut out that middle window. So I'd have to cut out, sorry, it was not a 0, it's a pi. Come on, eraser. Okay, I'd have to cut out pi in the middle, because it's not actually, f is not actually decreasing at pi, right? F is decreasing on either side of pi. So I prefer, so me personally, I always like to give the strictly answers, but the AP is probably going to be seeking you giving these answers instead, okay? So again, the short answer is that if f prime is positive, you're increasing. If f prime is negative, your function f is decreasing. All right, moving on. Okay, so again, we've already differentiated some of these before, so I'm just going to go ahead and find our derivative, right? It should be negative 2 sine of 2x. We found that the critical points happened at, so it happened at 0 and, so, sorry, I want an arrow there. The critical points happen when x is 0 and pi over 2 and pi, which we found again in the last video. F prime does not exist is not an issue, right? And there are n's, they are 0 and pi, but they already show up on the table, right? So when I make my chart, there's a couple different ways to deal with this. It's a little bit tricky if you write it this way. So one of the things we talked about in the last video was that you could also use a trig identity to rewrite this as a -4 sine x cosine x. Now this is my preferred method, but I don't know that everybody's going to see it that way. And that's fine, but that's what I'm going to do. So I'm going to use the trig identity that sine of 2 theta is 2 sine theta cosine theta, right? I'm going to use that to rewrite this way. So that means that my f prime, right, so we have 0 and pi over 2 and pi, right? This is quadrant 1. This is quadrant 2, right? So -4 is always negative, right? Sine is going to be, in quadrant 1, positive, and then it's going to keep being positive, and sine is 0 at the two ends, right? Cosine in quadrant 1 is also positive. It's 0 at pi over 2, and then cosine is negative in quadrant 2 because it's the x-coordinate on the unit circle. So I end up getting negative and positive, which means that f is increasing and then decreasing. So my answer is that f is increasing from, oh hey, I drew the arrows backwards, people. I said the thing backwards, it's fine. Decreasing and increasing. Come on, brain. F is increasing from pi over 2 to pi, and f is decreasing from 0 to pi over 2. By the way, that's an incredibly frustrating thing that you will do at some point where you're like, oh, I did all the math right, and then I totally drew the arrow in the wrong direction and answered it wrong. It's the worst feeling. All right, we already differentiated this before, so I'm just going to bust it out, right? So it's this plus this. Okay, so we got that it was this, which means that our only critical points, right, f prime was 0 essentially only when x is -1/2, because e to the stuff is always positive. F prime does not exist is not an issue, and there are no n's, right? There's no endpoints. So the only thing going on my sign chart other than infinities is that -1/2. All right, so I have an e to the 2x, and I have a 2x plus 1. So e to the stuff is always positive. And this is a line with a positive slope, meaning it's negative before it hits its 0 and positive after. I make sure I label my sign chart to say that this is f prime, right? Which means f prime is negative and then positive. So f is going down and then up. So my answer is that f is decreasing on the interval from negative infinity to negative 1/2. F is increasing on the interval from negative 1/2 to infinity. Ignore my inability to write like a functional human. All right. Same idea. We've already differentiated this, right? So I'm going to get this plus this. UdV plus VdU, right? In the last video, we also had already factored out a negative x e to the negative x, and we were left with an x minus 2. So we got that our critical numbers when f prime is 0, that's going to happen when x is 0 or when x is 2, that there's no spots where f prime does not exist, and that there's no ends. So what goes on my sign chart is, oh, my bad. Sorry, folks. That's a lot of slides. All right, cool. So what goes on my sign chart are just these folks right here and infinity. All right, so on my sign chart, here's my infinity, there's my 2, there's my 0, there's my negative infinity. I have a negative x, I have an e to the stuff, in this case it's e to the negative x, and I have an x minus 2. So here's my f prime, and here's my f. Okay. So again, I label everything so it's really clear what I'm talking about. So let's start with negative x. Negative x is aligned with a negative slope. So it's 0 at 0, right? But it's going to be the reverse. It's going to be above the axis before it crosses 0 and then below. E to the stuff is always positive. So e to the stuff is always positive. And x minus 2 is aligned with a positive slope. So it's got it 0 at 2. It'll be negative before it crosses that 0 and positive after. So I get negative, positive, and then negative. So my f is decreasing, increasing, decreasing. So when I answer my question, f is decreasing on the window from negative infinity to 0 and again from 2 to infinity. So negative infinity to 0 and 2 to infinity. And f is increasing on the window in the middle, which will be 0 to 2. All right, moving on. All right, on what intervals is f of x increasing? On what intervals is f of x decreasing? Same question. We've already found this derivative. So f prime of x is going to end up being, we figured out that it was an e to the x times a negative sine x plus cosine x last time, which means we figured out that the only critical numbers are at, let's see, 0 to 2 pi. We want when sine equals cosine, so that's at pi over 4 and 5 pi over 4. F prime does not exist is not an issue. And that there are ends, the ends are 0 and 2 pi. So the numbers that are going on my sign chart are these 4 numbers, right? So when I make my sign chart, and this one's a little bit trickier, right? When I make my sign chart, I have my 0, pi over 4, 5 pi over 4, and 2 pi, right? My factors are e to the x and a negative sine x plus cosine, which is going to be a little tricky, but we're going to talk about it in a sec. My f prime and my f. Okay, so e to the x is easy. It has no zeros and is always positive. Sine, so negative sine plus cosine is a little bit harder. So one way to think about this is to draw what slice of the unit circle you're looking at. See how in this slice the x values are bigger than the y values? See how in this slice the x on the unit circle is bigger than the y on the unit circle? Like this is longer than it is tall, right? Farther out than it is up. So if the x on the unit circle is bigger than the y, this is going to net positive. The other way to do that, if you really hate that idea, right, the other way to do that is to say, hey, I'm going to try pi over 6 because pi over 6 is right here in this interval. I'm going to plug in pi over 6 and see what happens. If you plug in pi over 6, you end up getting a negative 1/2 plus a root 3 over 2, which is definitely positive because root 3 over 2 is bigger than 1/2. The nice thing about this next window is this next window is huge. It goes from here all the way to here. So you could pick either of the two easy values. You could pick either pi over 2 or you could pick pi, right? So if you picked pi over 2, you're going to end up getting negative 1 plus 0, which is clearly a negative 1, and that's all you need to know, right? The last window is also like smaller, but not as small as the first window. You could pick 3 pi over 2. If you wanted to pick 3 pi over 2, you would get a positive 1 plus a 0, which is a 1, and you get a positive. Again, it's hard to do with some of these sines and cosines. It's easy if you're just being asked whether the sine or cosine is positive or negative, but when you're asked for the entire sine, or sorry, when you're asked for the sign plus something, a cosine or sine minus a cosine, it's harder. Sorry, I accidentally made that an f prime and then I got distracted. So when I go ahead and figure out what my f prime is doing, right? F prime is positive, then negative, and then positive again with zeros on those lines, right? So that means that f is going up, down, up. So my answer, if we squeeze this in at the bottom, is that f is decreasing in the middle window, which is pi over 4 to 5 pi over 4, right? And it's increasing. So it's not actually 0. F prime is not 0 on the ends, right? The 0 and 2 pi only showed up as endpoints. So it's increasing from 0 to pi over 4. 0 would be included because f prime is not 0 at 0. And from 5 pi over 4 until 2 pi, and again, 2 pi would be included for the same reason. So there's increasing and decreasing. All right. Again, we've already done this derivative. We found that f prime of x ended up being an e to the x secant x times a tangent x plus 1. So we ended up finding that the only critical numbers, right, so where f prime was 0, the only place where f prime was 0 was at tangent is -1, so that's going to be negative pi over 4. We found this in the last video. F prime does not exist, doesn't end up happening because the only time it would happen would be at like the pi over 2's, right? Because it's where cosine of x would be 0, but there's none in the interval, right? If you look at the interval we're looking at from here to here, this window. So there's no pi over 2, so that's not an issue. And we do have ends, right? We do have ends. They are negative pi over 3 and pi over 3. So we're going to go ahead and put those on a sign chart. So again, I get that trig sign charts are probably not the most fun thing in the world, but you'll survive. So negative pi over 3, negative pi over 4, and pi over 3. So again, it can be helpful. You don't have to do it this way, but it can be helpful to look at the interval you're looking at. Negative pi over 3 to negative pi over 4 is a very small window. It's this chunk right here. And then this one is from here up to like here, which is slightly better, but not great. It's only better because it does include 0, so you can plug that one in. So on my sign chart, I have an e to the x, I have a secant of x, and I have tangent of x plus 1. So when I go to find my f prime, e to the x is always positive. That's easy, right? We established that secant is never 0 on this interval, right? So here's the thing. The secant, right, secant is 1 over the x-coordinate. Well, I want you to notice that all of the x-coordinates in both of these intervals are positive. So secant has to be positive on this whole interval because the x-coordinate, both of the windows that we're looking at are to the right of the y-axis. They're both positive. So really it's going to come down to the way tangent behaves. So if you look at the value, right, this is in quadrant, so this right here, right, this is in quadrant 4, right? And we know that tangent is in general negative in quadrant 4, right? Here, tangent is positive, right? Here tangent is positive, but since it's tangent plus 1, in this entire window, it's going to net a positive. And you can see that by trying at x equals 0, right? Tangent of 0 plus 1 would be 0 plus 1, which is 1, so it's positive. You can make the educated guess here that what's happening is that down here the tangents are more negative than 1. And you can figure that out if you want. You can try. The problem is that there's no easy value to plug in to show that because unfortunately there is no value on the unit circle between negative pi over 3 and negative pi over 4. It's just not there. So, so you can intuit logically that what's happening is that here the tangent is more negative, then the tangent is 1, which means that tangent of x plus 1 is 0. Then the tangent becomes more positive so that it nets a positive value. So you end up getting a negative and a positive, which means that your f is going down and then up. So your answer would be f is decreasing from negative, oh sorry, it's a bracket because negative pi over 3 was not actually a critical number, to negative pi over 4, not included, and that f is increasing from negative pi over 4 to pi over 3. Again, the pi over 3 is included. All right. Last two, and then we're going to call it on this very lengthy video. So we've already done this derivative before, but we'll go ahead and walk through and find our critical numbers again. Low d high minus high d low. So I end up getting that this is a negative x squared plus a 1 on top of an x squared plus 1 quantity squared, right? What we figured out last time is that this numerator, right? This numerator right here is actually a negative 1 times an x plus 1 and an x minus 1, meaning that my critical numbers when f is 0 are at x equals 1 and negative 1. There are no places where f prime does not exist because x squared plus 1 is a positive number. It can't ever be 0. And there are no endpoints. So the only numbers that are going to show up on my sign chart are the -1 and the 1, and that's it. So I put the infinities on because you always have to have a sign chart that goes to the ends, and if there's no ends, the ends are infinities. My factors in the numerator are a -1, which needs to be on there, an x plus 1 and an x minus 1, and then the denominator is an x squared plus 1 quantity squared, which is so super duper positive. So I'm going to put d for denominator just so it's clear, and those are all in the numerator. The reason it doesn't matter that they're division is that multiplication and division function the same way. If you multiply two negatives, you get a positive. If you divide two negatives, you get a positive. Okay, so -1 is literally always negative, which is why it's a big deal if you forget it on your sign chart. Similarly, this is a super positive thing that is squared, which makes it even more positive. So that's always positive. The entirety of your problem is then going to hinge on these two middle factors. So x plus 1 is 0 at -1, and because this is a line with a positive slope, it is negative before it hits that 0 and positive after. The same thing will be true of x minus 1. It's just going to have its 0 at 1 instead. So what happens is I get 3 negatives, which nets negative, 2 negatives, which nets positive, and 1 negative, which nets negative. So what's going to happen is my f is decreasing, then increasing, then decreasing again. So my answer is that f is decreasing on the window from -infinity to -1 with a parenthesis and from 1 to infinity, and that f is increasing on the window between those two values, so -1 to 1. All right, last one, and then we're going to call it quits for today. So f prime of x, we've already done this one, but my brain is broken sometimes. Low d high would make that a 4x plus, so 4x squared plus 12 minus high d low. So we get 2x squared plus 12x on the top, and then an x plus 3 quantity squared on the bottom. So we found that our critical numbers happen at x equals, so this is actually a 2x times an x plus 6, which will be relevant later. So x is 0 and x is -6. F prime does not exist. That is an issue when x equals -3, but that's not in the interval. So it's not in the interval that we're given, and we do have endpoints. The endpoints we were given are x is -10 and -4. So that's what has to show up on my sign chart. So on my sign chart, I have a -10, a -6, a negative, oh hey, 0 doesn't show up in my thing. I should have noticed that in the last video, my bad. So 0 is a critical point, but doesn't show up on the thing, so that's all we need. Sorry, my bad. So we have a 2x and an x plus 6, and we have an x plus 3 quantity squared, right? Now you can list x plus 3 quantity squared as two separate numbers, or you can, or as two separate factors, or you can just recognize that it's squared. I really don't care. So 2x is going to be 0 at 0, which is all the way over here, meaning, so it's like 0 over here at 0, which is not even on the sign chart. This is going to be negative for all these numbers, and you can see it if you plugged in those values. X plus 6 is a line with a positive slope as well, so it's going to be 0 at -6, which means it's negative before 0, positive after. X plus 3 quantity squared is essentially a parabola with its 0 at -3. Again, -3 is all the way over here, right? But this thing is positive everywhere other than -3, so it's going to net positive, which means that my f prime is going to be positive and then negative, which means my f is increasing and then decreasing. So my answer is f is increasing from bracket -10 to -6 with parentheses, and f is decreasing from -6 with a parenthesis to -4 with a bracket, right? And again, in the last video, I should have noticed that this one is not in the interval. Same issue with the -3. All right, and that is it for our video.